Last episode, you wrapped a model in a Gradio app and shared a link in 2 minutes. But that app still drags the entire scikit-learn stack along with it just to make a prediction. So, here's the question. Can you ship the model without shipping the library that trained it? Think about what a trained model actually is. It's a recipe, a sequence of operations. Multiply by these weights, add this bias, take the max. The problem is that recipe is locked inside Python objects that only scikit-learn or PyTorch knows how to read. ONNX is a neutral language for that recipe. Instead of a random forest pickle or a torch state dict, you get a graph of standard operations, matmul, add, relu, that everyone agrees on. It's the PDF of machine learning models. Write it once, open it anywhere. And anywhere is the whole point. ONNX runtime reads that graph in C++, Java, CCOS, JavaScript on a Raspberry Pi in a browser tab. None of them import your training code. They just load one NX file and run it, often faster and lighter than the original. But a conversion you can't trust is worse than no conversion. So you never ship an export without a parity check. Run the original model and the ONNX model on the same inputs and prove the outputs match to a tiny tolerance. Same numbers or it doesn't go to production. Here's the whole thing in one file. We train a small classifier on the iris dataset, convert it to ONNX with a scale to ONNX, run both the original and the exported model, and assert they agree. Up top, we seed everything and train a logistic regression. Nothing exotic, the point is the export. The one line that matters is converts_learn. We hand it the fitted model and an initial types describing the input shape, and it walks the model into an ONNX graph. We write that graph to iris.onnx and immediately check its size on disk. It's tiny, well under a kilobyte, because it's just weights and operations, no Python, no library. Then we open it with ONNX runtime inference session, which is the engine that will actually run predictions. To run it, we call session.run, feeding the input array under the name ONNX assigned it. Back come the probabilities from the portable graph. Now we have two sets of outputs, sklearns and ONNXs, sitting side by side ready to compare. Run it. The session loads, the file weighs in at well under a kilobyte, and the parity line prints the max absolute difference between the two models on the order of 1i7, a rounding whisper, not a disagreement. And bet all close returns true. That number on the terminal is the same number on the figure card. The green parity bar shows both models landing on identical probabilities. The gap so small it's invisible. Figure equals terminal. The export is honest. Export once, run anywhere, and prove it matches before you trust it. Next episode, we take that same .onx file and make it fly, graph optimization and quantization to shrink and speed it up,